Okay, last one, you guys. We are learning a ton about math all in one day. We're going to do something really, really fast here. I'm going to try not to talk too much. We're going to do something called the second difference this time, and I'll show you why. Okay, so we're going to do two. We're going to do the first difference first. That's a one, first and second. Okay, so the first difference is going to be the bottom minus the top. 6 minus 5 is 1. 9 minus 6 is 3. 14 minus 9 is what, 5. And 21 minus 14, okay, y final minus y initial, the change in these two is going to be 7. Okay, then we're going to do it again. And we're going to say, here's our first difference, 1, 3, 5, 7. You can probably already see the pattern pretty easily right there. But we're going to do it again. We're going to say from here to here, 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. Okay. And something that's really cool is when you have a relationship like this, when the first difference is not the same, it's not a linear function. Okay. This is not going to be linear. It's going to be one of two things. It's either going to be quadratic that looks kind of like this or like this. Or it might be something called exponential. Let me show you what that kind of looks like. Exponential looks kind of like this, where it starts short and goes to a higher slope, or maybe it starts with a really high slope, like this. It's super steep, and then it shallows out and follows the x-axis or the y-axis or something. Okay, those are called exponential. So. But what is kind of cool is, again, another tool that nobody taught me for many, many years, is that if your second difference is the same, then you automatically know that this function is going to be quadratic. So it's going to be a parabola. It's going to look like this, something like this. It's going to either be like this or like this. And there's lots of ways that you can find out how that looks. But the first thing I would probably do is just graph the thing. So I will do that really, really fast for you. They've already given you a whole bunch of data points, so you can just stick them in here. Let's see, the y's have to go from 5 all the way to 21, so maybe we'll go by threes. Go 3, 6, 9, 12, 15, 18, and 21. Okay, and there's not any negatives in the y's. And the x's are all positives also. 1, 2, 3, 4. Okay. Where the x is 0 and y is 5. Let's see, what did we say? 3, 6. So 5 is right here. Where x is 0, there's our first little dot right there. Where x is 1, y is 6. Where x is 2, y is 9. Where x is 3, y is 14. Let's see, 3, 6, 9, 12, plus a little bit is 14. And this one, it's going to be like this. Okay. And I have this hunch that if we plugged in, if we knew what this formula was, this looks like this so far. But I think if we knew what the formula behind this chart was, like if we knew what f of x is equal to something over here, if we knew what this something is, I think that if we plugged in the negatives, we'd get the same, like we'd probably go like this. Okay. That's what my guess is if we did the negative numbers, if we did x is -1, -2, -3, and things like that. So that would be kind of fun to find out what those numbers would be. Anyway, that's kind of where we're at for this one. I'm not going to go very much more into that. Just know the most important part on this little one that we're talking about, the things that we will have talked about in class, is going to be this second difference. So if you write in your notebook, if the second difference is the same, the function is quadratic, which is so cool. And you can like draw a little picture that looks kind of like this, like this. That's quadratic. Okay, something that's either up or down. Okay. All right. Let's go ahead and be done with these. If you see or notice any other cool similarities, you can write those down too.